Good evening. Back with our class on structure of atom. Yesterday we studied discovery of electron in a cathode ray experiment. We said that when you take a glass discharge tube and fill it up with a gas and an extremely low pressure is applied, gases ionize and conduct electricity. We take two electrodes, a negative and a positive electrode. The negative electrode is called as the cathode and the positive electrode is called as the anode. When I fill it up with gas, some invisible rays travel from the cathode and move towards the anode. These rays are called as what rays? Cathode rays. Cathode rays always move in a straight line as they cast the shadow of an object. Cathode rays move with a very high energy because when a paddle wheel is placed in the path of cathode rays, it rotates. Okay. Then when placed in an electric or magnetic field, cathode rays always get deflected towards the positive plate, which shows that cathode rays are made up of very small particles which are called as what? Electrons. So cathode rays and tashna electron. So let us write today charge of an electron. How much is the charge of an electron? Minus 1.6 into 10 to the power of minus 19 coulombs. Charge of an electron is 1.6 into 10 to the power of minus 19 coulombs. 1.6 into 10 to the power of minus 19 coulombs is the charge of the electron. Okay? It actually 1.6 altane paristiti for your calculations. Minus. So it is minus 1.602 into 10 to the power minus 19 coulombs. Actual number. But yesterday now 1.6 into 10 to the power of minus 19 coulombs. Mass of electron. Mass of electron is 9.1 into 10 to the power of minus 31 kg. Mass of an electron is 9.1 into 10 to the power of minus 31 kg. Okay? If it is 10 to the power minus 31 means it is very small. Okay? So this is all about cathode ray experiment where we discover electron. The charge of an electron is minus 1.6 into 10 to the power of minus 19 coulomb. The mass of electron is 9.1 into 10 to the power of minus 31 kg. Now we will talk about mass of proton because we discovered what rays? Canal rays or anode rays. What was anode rays? We took what cathode? Perforated cathode. Okay, we took perforated cathode. Now let us make this clear. We took perforated cathode. I will change the sign. This becomes the cathode and this becomes the anode. So some invisible rays travel from here and they produce a glow here. This is called as what rays? Anode rays. These anode rays, when placed in the path, they always move in a straight line. If a solid object is placed, it casts its shadows. It moves with a very high velocity, and when placed in an electric or magnetic field, it gets deflected towards negative plate, which shows that anode rays are made up of positively charged particles, and these positively charged particles are called what? Protons. So charge of proton or charge on a proton, same thing but without a negative sign. 1.6 into 10 to the power of minus 19 coulomb. That was what? Minus 1.6. This is 1.6 into 10 to the power of minus 19 coulombs. Actual value 1.602 into 10 to the power of minus 19 coulomb. And mass of proton. Mass of proton is 1.676 into 10 to the power of minus 27 kg. 1.676 into 10 to the power of minus 27 kg. Okay? So now the first model of atom what we studied was called as what model of atom? Thomson's model of atom. We said in Thomson's model of atom, an atom is a ball of what charged particles? Positively charged particles with electrons embedded here and there like seeds in the watermelon. Isn't it? This was what is the Thomson's model of atom. But this model was rejected because we always say atom is what? Neutral. Electrically neutral. That means the number of positive charged particles should be equal to the number of negatively charged particles, which is not happening in this case. Then we went to the next model of atom, which is called as what? Rutherford's model of atom. Okay. Now technically, yesterday very foolishly I thought, today I will teach technically. So Rutherford model of atom is also called as the planetary model of atom or the solar system model of atom. Fine? It says what we do here is we take alpha rays. What we take? Alpha rays, which are what rays? Positive charge rays. What are alpha rays? They are doubly charged helium atom. Yella notes doubly charged helium atoms. Okay, so alpha rays are what? They are positively charged rays. They are doubly charged helium atom. And why are they taken? Because they have high penetrating power. They have high penetrating power. Penetrating under? You can go inside. You can penetrate through the atom. So why is alpha ray taken in Rutherford's experiment? Alpha rays are positively charged rays moving with a very high velocity and they have very high penetrating power. What we do in Rutherford's experiment is we take a gold foil. Gold foil go to silver foil tintira kaju barfi mele. So same way you can even have what? Gold foil. Why did he choose gold? Because gold is the most malleable metal. Malleability can be drawn into thin sheets. Ductility means wire. Okay, malleability means can be drawn into very thin sheet. So why did he choose gold? Because it is one of the most malleable metals. And how thin he made the gold foil? He made it as one atom thin. Not 2-3 atoms together. It should be what? Like one atom thin. The gold foil was made. And now through this he passed what? Alpha particles. Then Pradhanya's experiment. What was Pradhanya's experiment? Most of the alpha rays went straight, which proves that atom is hollow. 1 out of million rays came as it turned back, which proves that it consists of a solid nucleus where all protons are present. Whenever they met an electron, they got deviated. Okay, so what is Rutherford's model of atom? It states that atom basically consists of a hollow sphere with a solid nucleus. All the protons or positive charged particles are concentrated at the nucleus. The electrons revolve around the nucleus. The electrons revolve around the nucleus. This is what is called as Rutherford's model of atom. It is also called as alpha ray scattering experiment. Okay. Rutherford model of atom is also called as gold leaf experiment or gold leaf scattering experiment. Alpha ray scattering experiment, gold leaf scattering experiment is one and the same. What we did? We took gold foil and bombarded it with alpha rays. Most of the alpha rays went straight, which proves that atom is extremely hollow ball with a positive nucleus at the center. What is present in the nucleus? All the protons are present in the nucleus. The size of the nucleus is very small when compared to size of the atom, and then the electrons revolve around the nucleus. So the nucleus becomes the sun and the electron becomes the planet. So they move around the nucleus. Artha Pakka? What is Rutherford's experiment? Take gold foil. Why do we take gold foil? Because gold is the most valuable metal. It can be drawn into a very fine one atom thin sheet. Then we pass through it what? Fast moving beam of alpha rays. These alpha rays go straight, which show that atom is extremely hollow. 1 out of a million rays hit a solid object and turns back, which shows that at the center there is a very small nucleus where all positive charge particles are present. The size of the nucleus is small when compared to the size of the atom. The electrons revolve outside the nucleus. Correct? Understood Rutherford's model of atom? Now the Aryan's experiment. What did we say? If the electron constantly revolves, what will happen? There will be loss of energy, and ultimately a time will come when it will fall into the nucleus of an atom. See, this is what is Rutherford model of atom ka defect. What is Rutherford model of atom ka defect? This is my nucleus. If the electron constantly revolves, there will be loss of energy. It will shorten its path, and ultimately a time will come when it will fall into the nucleus of an atom. So this is not correct. Rutherford could not explain that why the electron will not fall into the nucleus of the atom but will stay outside the nucleus. Who questioned it? There was a scientist called Niels Bohr. Who was he? Niels Bohr. So now which model of atom we will study? Bohr's model of atom. What is the drawback of the Rutherford model? That if an electron constantly revolves in a circular path, there will be loss of energy. And as long as there is loss of energy, it will shorten its path, and ultimately a time will come when it will fall into the nucleus of an atom, which makes atom unstable. So Niels Bohr, when he questioned, Rutherford could not explain as to why the electron will not fall into the nucleus of an atom. So this model of atom was rejected. Okay, now we come to which model of atom? Bohr's model of atom. But before we come to Bohr's model of atom, there was discovery of neutron. Till now we were talking about what? Only electrons and protons. Now we will have discovery of neutron. Discovery of neutron. Okay, so now Chadwick took beryllium atom. Which atom? Chadwick took beryllium atom. Okay, beryllium atom has 3 electrons. Fine. So it has a nucleus and it has 3 electrons. 2 electrons in the first orbit and 1 electron in the last orbit. So it also has 3 protons. 3 electrons, 3 protons, because the number of electrons are always equal to the number of protons. Right? So let us imagine that beryllium atom is present. Hydrogen, helium, lithium, beryllium, 4. So it has 4 electrons and 4 protons. Fine. Now what he did was, he bombarded them with fast moving beam of alpha particles. Alpha particles are high, moving with very high velocity. So when you bombard them with fast moving beam of alpha rays, all the electrons were removed and they were escaping out into the space. Then protons were also thrown out. Then there should be nothing, no? Because electrons and protons are only present in the atom. So what he said, that if the electron is removed, if the proton is also removed, then he tried to weigh if there is something there or not. He found that there was some particle which neither has any charge but had a mass which is equal to 1. Such particles which do not have any charge, because when placed in electric or magnetic field, they neither move towards the positive plate nor move towards the negative plate. So they were what in nature? They were neutral in nature. Such particles which were neutral in nature but had a mass of 1 but charge was 0. Electron mass 0 and charge -1. Proton mass 1, charge ಅರ್ಥ ಆಯ್ತಾ? So this is neutron. Neutron mass is 1 but charge 0. So this is how neutrons were discovered. And then he said that neutrons are present along with proton in the nucleus of the atom. So now we have how many parts in the nucleus? Protons and neutrons. And what is it? The electrons revolve around the nucleus. Gottaita discovery of neutron? Chadwick bombarded beryllium atom with fast moving beam of alpha rays. He found that first the electron was removed, then the proton was removed, and then he kept on waiting to see whether there is some mass, some element is present or not. He found that they were not charged particles which were called neutrons. So as they were having no charge, Chadwick named them as neutrons. Neutrons are present in the nucleus of the atom along with proton. Now let us study today Bohr's model of atom. Nale compass tarbeku. Compass and pencil tarbeku because all structures in ಪರಿಸ್ಥಿತಿ. Okay. So now for ನಾಳೆ ಬೆಳಗ್ಗೆ ಮಾಡಬಹುದು ಕ್ಲಾಸ್. Is it possible? I have class on this time. Okay, well, let me see. So now Bohr's model of atom. See, what does Bohr say? Atom is made up of a solid nucleus at the center where there are protons and neutrons. Electrons revolve around the nucleus in fixed orbit or energy levels, which we name them as what? K, L, M, N. He named what? Why he did not name it from ABCD, I don't know. Okay, he named them as shells as what? K, L, M, N. Okay, so first thing, what did he say? That always the atom has a nucleus which has protons and neutrons. Electrons move around the nucleus in fixed orbit or energy levels. Now what does it mean? Let us suppose K has 5 joule energy, L has 10 joules energy, M has 15 and N has 20 joules of energy. Correct? So now if the electrons revolves in 5 joules, its energy will always be 5 only. So what did he say? As long as the electron is revolving in a particular orbit, there is neither absorption of energy nor emission of energy. When it jumps from lower to higher orbit, it will absorb energy. Because 5 is again 10. So it will absorb energy. But when it jumps from higher to lower orbit, it will radiate energy. The difference in energy, delta E, is given as E2 minus E1, where E2 is energy of higher orbit and E1 is energy of lower orbit. Again, what did Bohr's model of atom say? Atom consists of a solid nucleus which has protons and neutrons. The electrons revolve around fixed orbit or energy levels, which are named as what? K, L, M, N, O, whatever it is. As long as the electron is associated with an energy level, each orbit is associated with an energy level. As long as it is moving in a particular orbit, it neither loses So it will not come back and fall to the nucleus. Artha aita? Because it is associated with a fixed amount of energy. As long as it is having 5 joules, it will keep rotating here. It will not go back and fall into the nucleus of an atom. Clear? When it jumps from lower to higher orbit, it absorbs energy. And when it jumps from higher to lower orbit, it radiates energy. Is it clear? One more time. What was Thomson's model of atom? Atom is made up of, atom is a ball of positive charged particles with electrons embedded here and there like seeds in the watermelon or like seeds in watermelon. Correct? Next was what model of atom? Rutherford's model of atom. What was Rutherford's model of atom? That atom consists of a solid nucleus which has protons in it and electrons keep moving around the nucleus. What was the drawback of Rutherford? He couldn't explain that why when the electron constantly revolves, there will be loss of energy and ultimately it will fall into the nucleus of an atom. Now who came and explained? Bohr came. Niels Bohr said that an atom always consists of a solid nucleus with proton and neutron. Electrons always move around in fixed orbit or energy levels. Each orbit is associated with a fixed amount of energy. As long as an electron revolves in a particular orbit, there is neither emission nor absorption of energy. When it jumps from lower to higher orbit, it absorbs energy, and when it jumps from higher to lower orbit, it radiates energy. The difference in energy is E2 minus E1. Clear? We'll stop here. But what I expect you is, as I have already sent you the notes, I expect you to take a printout and read till here. Because if you don't understand this, tomorrow's class, which is Skandan's favorite class, because this is what is going to come for his exam, he will be in mess. So please read. Okay? Sure. Thank you.